Okay, so a couple of things just to point out to you here is that don't mind this page. This is just for my own guidance because I can't look at the book and because the book's on the iPad and I'm recording this video with my iPad, so I have to use a kind of just a little guide for me here. All right, so we're looking at linear patterns, and the first thing I'll just say about patterns is that you may wonder why we bother studying them at all. And the point is that a lot of things in nature occur in patterns. If you just think of floral patterns in the petals on leaves and things like that, or on flowers as well, patterns are very appealing to human beings. We like things to be in order, so patterns can be quite interesting in that regard. So the first thing we're going to tackle is we're going to look at linear patterns. All right, and the first example of a linear pattern is they say that we are given 5 marbles, a blue one, an orange one, a green one, and an orange one. And they say that this pattern repeats again and again and again and again and again and again and again, right? And it goes on and on and on. And the first question says is, find the color of the 89th marble. Okay, so you could do this a long way, and you could draw out your sequence again and again and again and again and again and literally count all the way to the 89th marble, but there's actually an easier way. So think about this logically. If we have 5 marbles, that means we divide 89 by 5 and I get 17 remainder 4. Now if you just notice, I put 17.8 there. 17.8 is what would come up on your calculator if you divide 89 by 5. You get 17.8. But remember, a fifth, because this is in fives, a fifth is 0.2. So there's 4 0.2s here. Did you get that? There's a remainder of 4. So what does this mean for us? So every 5, so there's the 5th one, there's the 10th one, 15th, 20th, 25th, all the way up, right? So the 85th is just behind this mark here, which would have been an orange marble, all right, based on the pattern. So 85th, 86th, 87th, 88th, 89th. So my 89th marble is going to be green, okay? So 89th marble is green, okay? Is that all right? I hope that's visible enough. I know that's a bit of a light color. So we know that the 89th marble is green. Another question they have for here is, what is the color of the 100th marble? So color of the 100th marble. Same thing again. Okay? We have a pattern that's repeating every 5. So 100 divided by 5 gives me 20 with no remainder. Now that's really important. 5 goes into 100 evenly, which means that you're going to end on an even number. So 5, 10, 15, 20, 25, 30, 35, 40, all the way even. So that means that your 20 or 100 marble is going to be orange. All right, think about it, because 5th, 10th, the 20th would be orange, the 30th would be orange, so why not the 100th marble as well? So the 100th marble is, what did we say it was? Orange. Sure, look at me, I'm drawing it. Orange. Okay, the 100th marble is orange. Is that okay? And then it says, how many times does the blue marble appear in the first 32 patterns? Okay, so what it means is, if I repeat this pattern on and on and on and on and on, all the way up to the 32nd one, how many times does the blue marble appear? Okay, so 32 divided by 5, 32 divided by 5 is equal to 6.4, which in other words is 6 remainder 2. So it means that the 5 patterns get as far as 6 and then you have a remainder of 1, 2. Alright? So that means that the 2 blues together have occurred 6 times. So 6 multiplied by 2 is equal to 12, but then there's a remainder of 2. There's your first remainder, there's your second remainder. So I'm going to add 2 onto that. So 14 is how many times the blue marble has occurred in the first 32 marbles. Now I'm going to pause just to move on to the next part here. Remember guys, the whole point of this is, if there's anything I've done that doesn't make sense, you rewind, have a quick look. And don't be afraid to say to me now in the class if there's anything I could have made clearer or things I could do better. Okay? We've looked at linear patterns. Now we're going to look at a linear sequence. Okay? So we're going to use this example here. Alright? So if I said that this was a pattern or a sequence, 4, 7, 10, 13. Alright? And I asked you to identify what the next one would be. I'll give you a couple of seconds to think about it. Okay, so if you think about it, if you look, it's going up by +3, plus 3, plus 3. It's going up by 3 every time. So 16 would be the next one. 19 would be the next one. Okay? And so on and so forth. This pattern can continue on for infinity if you want to look at it that way. Alright? So, some of the questions will start, but they'll give you a sequence like this. And the first thing that they've asked here is write t of 1. Now, so whenever we're talking about linear sequences or terms, t of 1 just means the first term. First term, okay? So, t for term and the 1 for first term. So what's the first term in this sequence? Well, it's 4, okay? Because you can see it there by itself. Fourth term there, okay? The next thing they ask then is find the first difference. Well, I've kind of done this for you. Okay, the first difference is a plus 3, a plus 3, a plus 3. So the first difference, which is given the letter D, alright, is equal to plus 3. It's important when you're talking about differences, make sure that you say plus 3, because linear patterns can go down as well as up. This could be minus 3, minus 3, minus 3. Alright, so including the sign is important here. The next one is, it says then, so remember this, our terms are, this is what we were given, 4, 7, 10, 13. It says the next 3 terms is what it's looking for here. So I've just done it here. You add 3, and add 3. That's going to be 22. So 16, 19, and 22. Okay. And finally then it says describe the sequence. Okay, describe the sequence.
Okay, so sequence is increasing by a common difference of plus 3. It is a linear sequence.
And that is literally the definition of a linear sequence. It is one that increases or decreases by the same amount every time. And just a quick note, guys, that this part of the question said first difference. You can actually have a second difference, but if we look at the second difference of this, so the difference of the difference, there's no difference. Plus 0, plus 0, plus 0. We're going to see some patterns, not in today's video, but in future video we're going to see where a second difference and even a third difference can come in. Alright, but don't worry too much about that for the moment. Just going to have a look at a very similar question with a slightly different sequence, okay? So, this time the sequence will be reducing 7, 2, minus 3, minus 5. Sorry, minus 8. Okay? Give you a second to think about what the difference here might be. So this time the sequence isn't increasing, it's decreasing by 5 every time. Minus 5, minus 5, minus 5. So those questions are, write the first term, t of 1. Remember, this is term, this is first. So t of 17 would be the 17th term, okay? So don't worry about that for the moment. So t of 1, first term is 7. Then it looks for the first difference. First difference is equal to minus 5. Alright? Write down the next 3 terms. So I've just run out a bit of space there. So we have 7, 2, minus 3, minus 8. And we know that it's going down by 5 every time. So just take 5 away, I get minus 13. Take 5 away, I get minus 18. Take 5 away, I get minus 23. Alright? Okay? And just to say that, because this is a perfectly acceptable way of showing your work. Alright? So the next 3 terms are minus 13, minus 18, and minus 23. And then it says describe the sequence in your own words. Now using what we said over here, instead of sequence is increasing, we say sequence is decreasing by a common difference of minus 5. It is a linear sequence. It has a common difference, therefore it is a linear sequence, okay? So just a quick note, if a sequence has a common difference, which is the letter D, alright, it is linear. Okay? It has a common difference. It is linear. Okay? Alright, so pausing this one again and moving on to the next part and last part of this video. Okay, so the last part of this video, guys, we're going to tackle what are called general terms. So a linear sequence, remember we said, can be infinite. All right, you can add 2 to a number, so you can go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. It's got a common difference of plus 2, and you can do that forever and ever and ever. So what's often done is it's better to deal with what's called a general term, which we give the symbol. So t for term, and this time our general term means t of n. Is that okay? So t of n is what we call our general term, and you're going to end up. This does have a tiny bit of algebra in it, so you might end up with something with Tn is equal to 2 times n plus 1. So what does n actually mean? N is the term. So let's say I want to find out what is the number of the 10th term in this sequence. So when n is equal to 10, I just sub 10 in for n. So t of 10, again, t for term, and 10 is the number of terms. So to find that out, wherever I see n, I sub in 10. 2 times 10 plus 1 is equal to 20 plus 1, which is equal to 21. So we don't know a lot about this sequence, but we do know that its 10th term is 21 because we knew its general term. All right, so we're going to work out how to find the general term of different patterns, okay? Okay, so I've just took a moment there to set up the question. So the question says, find the general term of the following linear sequences and hence find the 25th term. So there's that word hence that we mentioned the other day. When you see the word hence, it means it wants you to use what you've just done. Okay? So find the general term of the following linear sequence. Well, there's our linear sequence. 8, 19, 30, 41. I'll give you a second to see if you can think of the common difference there. And it's plus 11. Okay? So plus 11 is the common difference. It's going up by 11 every time. So the next sequence would be 52, and the next one would be 63, and the next one would be 74. Okay, so let's have a look. What have I done down here? So the first term is 8. All right, and this is a handy thing you can use to work out how to find the general term. So t of 1 is the first term. So I take the common difference and multiply it by 1. So you multiply the 11 by 1, and it gives me 11. Then I ask myself, how do I make that 11 get back to 8? And I take away 3. See that? So 11 multiplied by 1. So I got the 1 from here, multiplied by 11, because that was my common difference, and I get 11. So how do I get back to my term number? I have to take away 3. That gives me 8. Alright, and there's my first term. Now that might seem a little bit convoluted, but this will make sense in a second. So let's have a look at the second term. The second term is 19. So if I take the common difference, which is 11, multiply it by 2, the second term gives me 22. How do I get back to 19? I take away 3. Gives me 19, and there's my second term. So what am I doing for t of n? So it's 11 multiplied by, this time I don't have a number, I just have the letter n. So it's 11 multiplied by n, which is just equal to 11n. Alright? So I've done nothing different. That's 1 multiplied by 11, this was 2 multiplied by 11, this is n multiplied by 11. I get 11n. And I know based on these two that if I get this number and take away 3, I'll get back to the term that I have. So 11n minus 3 is the general term. This is the nth term. If I want to find any particular number, I sub it into n and I'll find it out. So remember, the question did say hence find the 25th term. So in other words, n is equal to 25. And now I have my general term. So it becomes 11 multiplied by 25, and then I'm going to take away 3. So 11 multiplied by 25 is 275, minus 3 is going to be 272. Okay? And that is the 25th pattern. Now I could go on and on and on, so I could go, I say 52, 63, 74, 85, 96. We could go on and on and on all the way to the 25th pattern. It'll take a while though, and I should mention that this is a legitimate way of getting your answer. Unless it says something specifically like, well, you'd only get, actually, sorry, I take that back. You wouldn't get full marks if you did it this way. You get some marks for finding the 25th term, but you wouldn't get any marks because you didn't, or you wouldn't get any marks for not finding the general term. So you only get some of them, okay? Now remember, if that video didn't make sense the first time, rewind me. That's the whole point of what we're doing here, okay? So we'll try some of these exercises in class, all right? See you then.